go for a Google search. Then you will find the first link. So you will get like this, welcome to Colab. If you're coding directly, what you can do is just see this code tab now. You can just type whatever, like I'm giving, just give the run. So this arrow mark is the run button. Okay. In Jupyter Notebook, we give the run now similar to this. Okay. So you just give a like simply like a equal to 5, b equal to 10. Then I'm just telling it to print a. That's it. This is the code. If you want any extra tab, you just give this code. Plus sign. Okay. This plus sign will give you the extra cells where you want to code. It's a cloud platform, right? So no installation, nothing. In each cell, no, you can give this plus sign, and then if you want to run anything, you can just press this run cell here, no, this arrow mark, like a play button is there to your left. Yes, guys, got it? Fine with Colab? Then I'll tell you how to upload the file, coding file to that. Once you're okay with it. You go for file, new notebook, then you will get a new page. Now, if you want to upload that file, what you have to do, go to the file and then give upload notebook. In the file, you will have an option, upload notebook. Then choose the file which you want to upload. So it will be there in your downloads. Wherever you have saved my coding file, it will be there. Just click it, select it, and then give upload. It will get uploaded. That's fine. Able to upload. So before entering into the concept, so like you want to know about some basics of machine learning that I'll explain you. So in machine learning, as I told about the linear regression, in linear regression, you have an independent variable that is x and a dependent variable y. So our equation will be y equal to mx plus b. So while you're coding, suppose if in your data set, there are like 1,000 data are there. Okay, so in your data set, there are 1,000 data are there. Now, what we do, we split the data set into two. Okay, so how will we split the data set? We'll split the data set as training data set and testing data set. What is this training and what is this testing? So training is nothing but, so like you are learning for your exam. Okay, so you're learning for the exam, and then finally in the exam they will test you, right? So they will, now you will have like 5 units. You're learning all the 5 units. They are not going to ask each and every page. Like if there are 100 pages, they are not going to ask each and every page in your exam. They will ask like randomly, they will pick some 10 pages. That 10, from the 10 pages, the questions will be there. So this is same concept only here. So if there is 1,000 data are there, we will not take all the 1,000 data to train or test. We will divide this data set into two, 80 or 80-20 or 70-30. What is this 80-20? 80-20 is nothing but 80% of data set I will take it as a training, and 20% of data I will test whether it is learned properly or not. Okay, so what is 80% is nothing but 800. 800 data set I will take it as a training, and 200 data set I will take it as a testing. This is how we do in the machine learning algorithms. Okay, so in the machine learning algorithms, we will divide the data set as a training and testing, and then we will see how accurate my algorithm is learning the data set. So what we are doing in machine learning, there are algorithms are there. Depending upon the data set, we use the algorithms. We give data, and we will tell the algorithm to learn it. such that when you are giving a new data, it has to predict the output correctly. So that we call it as the model. Your model will be based on the algorithm. So you already with the data set, you will train your model. So when you're giving a data set, you will check whether it is predicting correctly or not. Okay, it should correct. So before giving new data, what we are doing in this data set itself, I'm picking some 20% of data and I will test my model whether it is working properly or not. So we will check using the error formula. We saw no, like RMSC square. Then in if it is a logistic regression, we use accuracy score. So like these concepts are there. Using this concept, we will check how accurate. This is nothing but your marks. If you're getting 80%, okay, you are good. 90%, very good. If it is 70%, okay, fine. Then if it is 50%, we tell them it is an average. Okay, so then we tell, okay, you have to concentrate more. Okay, so similar to that, we will tell our model or we will tell it, see if it is 85%, okay, fine, I can work on this data set. Okay, this prediction is good. But when you're working in a healthcare data set, you're predicting like diabetics or cancer, that case 99% it should be accurate. Then only a model will be good. Because if it's 85%, then you're telling it to predict whether the patient is having cancer or not. Because of 85% accuracy, if it is missing one person, even if one person who is having cancer, it is predicting wrongly, no, is not cancer, then it will be problem, right? In healthcare data set, we have to be very careful in the accuracy percentage. Other data set, it is okay if you are achieving 90% or no, so that will be fine. It will predict almost very good prediction you will get. Okay, so that's why now this is in machine learning. Okay, so in machine learning concept, we give the data set and you find the output. That is only one layer, input layer and output layer. But deep learning, I told you, there will be input layer, then hidden layers, then output layer. Okay, so this is how deep learning will work. So now in deep learning, you want to keep the hidden layers. That's all we have to give, right? So for that, we need some libraries for that. So that library is TensorFlow. So how you are taking NumPy as NP, similarly TensorFlow, I'm taking it as TF. Then in TensorFlow, I'm taking Keras. Okay, Keras is I told you, is a framework or API. So which is very for beginner level for doing deep learning. Keras will be very user friendly. Then from Matplotlib, you know, for the graph, we have Matplotlib, and then other one is we have Seaborn. Same Matplotlib, and then we are using NumPy functions. Okay, these are the libraries. First, I am downloading it. Okay, so now I told you in the Keras there will be data set. So usually we take data set from outside and we will upload it, right? But in Keras there is a data set MNIST. Okay, MNIST data set. And what I'm telling it is I'm telling it to load the data. So when you give this function load data, so in Keras there are data sets. Some data sets are there. You can just go to the official Keras website and you can see what are the data sets present. You can find many data sets there. Okay, you can tell Keras dataset, and then in that I'm taking the MNIST dataset. Okay, I'm telling it to load. Okay, so the dataset will get loaded. As I told you, in this dataset, you can split the dataset as X-train, Y-train, X-test, and Y-test. Okay, already inside this dataset has got split. So I'm taking it this as separately. Guys, once you finish the machine learning, this part will be very easy. So now you learn what is happening here, understand what is happening here. So once you finish machine learning and again you are revising it, it will be very clear. Okay, how it is all working. Okay, so now just understand how the code is working. Since you came directly to artificial intelligence, maximum I'm telling you the basics, then while I'm covering this. But when you're learning machine learning and coming here, it will be more like you will understand more clearly. Okay, now what is happening, you understand it. So then once you finish it, revise it again, so you can do this coding very easily. Okay, This is for Anuradha and Hemant because you came directly from Python to, so you will feel little difficult. That's why. Then if you see the length of the data set, it is a 60,000. Okay. And testing actually total data set is 70,000. It is splitted in the ratio like that, such that in the training, it is the length of the data set is 60,000 and the test it is 10,000. So total data set will be around 70,000 data are there. Okay. So data set will be splitted into two, training and testing. Just now I explained, no? In training, there are 6,000 data are there. In testing, there are 10,000 data are there. Okay. So in this 6,000, there will be both dependent and independent variables. So this is a independent and this is dependent variable. Similarly, in testing, there will be independent and dependent variables. What is y equal to mx plus b? Now, if you are what I can tell, okay, if you're predicting for a diabetics patient, okay, so what you will predict whether the patient is having diabetics, yes or no. Okay, this yes or no is my dependent variable y. Okay, and x will be like depending upon the patient BMI, age, they will have the diabetics, right? So based on this x value, my y value will differ. So this x is a x we called as independent and y is a dependent. Yesterday's class, if you see the recording, I would have explained in the house price prediction. Same thing only. The price of the house will be depend upon the area and the square feet. So area and the square feet are independent features and house price are dependent features. Okay. And if you see the shape, okay, I will explain this data set out with this. So now it will be like having shapes like 1, 2, 3, 4, everything. And it will be in the form of a pixel. So this pixel will be 28 rows and 28 columns. Normally, any image files, no, it will be of this 28 into 28 only. Any picture you're taking, no, so this will be between 28 to 28. And how this will be there if there is 2 over here. This is a picture of 2. Okay. Then this here all it is white color and this 2 alone is blue color, right? So there alone the pixel range. So wherever it is white color, it will be the value of colors will be 0, 0. So here all it will be 0 because there is no images. Okay. Wherever 2 is there around some values will be there, like 234, 235, 255. Okay, if it is clear, it will be 255. If it's not clear, around 250 or 240. So only around this place where the 2 images are, this numbers will be there. Wherever the white place are there, 0 will be there. Okay, so this is how normally whatever the picture you take, the pixels will be there. And if we are going for colored image, it will be like red, blue, green. RBG will be there. That I will explain you in the next coming class where we learn about computer vision CV. Okay, so that time I will explain about RBG. Now we are taking only the black color, so it will be like this 234, 235. This range the values will be there. Okay. So that shape, this shape function you have studied in NumPy and Pandas. Shape function will give you all the rows and columns, right? It contains 28 rows and 28 columns. Okay. So if now it is 0 in 0 index, what is the see if you see here, only wherever the blue colors are there, there alone the numbers are there. Others all it contains 0, 0, 0, 0. Okay, wherever the numbers are there are on the numbers. Others, like if the 2 is present over here, only this area the numbers will be there. That is what it is mentioning, 154, 253. Other areas all it will be like 0, 0, 0. Okay, so this will be in the form of a matrix like this, 0, 0, 0. Then wherever it is 2, no, 250. 253, 251, like that the numbers will be there. This is the matrix there. Okay, this is first row, then this is second, third. So that is what here, first row, second row, third row, fourth row, fifth row, like this. Next, if you want to see this in the using matplotlib, you can plot this, and if you see, so this is the shape in x underscore range. The shape is like a 5. Okay, so it is like a 5. So y train is telling it is 5. Okay, in x it is showing the image, and y train is telling it is 5. Okay, this is the scaling concept. We will remove the scaling. Okay, I'll explain what is scaling. So scaling is scaling or normalization we use in machine learning or deep learning when your data set is having a range, very large range. So if you see here, our range is between 0 to 255. Okay, so that case, what we do, if you do the scaling, the values will be between 0 to 1. So for the scaling purpose, I'm giving 255. Just what you do in your coding, you remove this 255 and check what answer you're getting, and then you do this 255 and check what is the answer you're getting. So now what I'll do is, this was some comment. Then this line, what I'm doing is I'm flattening. Flattening is nothing but I'm converting this 2D into a single two-dimensional into a two-dimensional into a one-dimensional array. So what I'm doing is I'm using the reshape function. Okay, I'm giving the length and then I'm converting it into 288 into 288. I'm reshaping the functions. So this reshape function you would have studied in NumPy. Okay, so I'm reshaping the values. Okay, and similarly, X-train, Y-train, everything I'm reshaping. Sorry, X-train and X-test, both I'm reshaping here. Okay. So when you are reshaping, it will become, so normally it is 28 into 28. This 28 into 28, I'm converting into a single array. So 28 into 28, you will get it around 784. So that is what it is doing here. Okay, so using reshape function, I'm just changing the shape. Okay, shape of the array. We have two methods. We can do manually the flattened shape there, right? See, how this will work is, first the image. Okay, any image. Now, like I'm giving a image of number 2. Okay, let us keep the image of number 2. This image we can't give it to the algorithm directly. So what we have to do, we have to convert them in the form of a matrix. Okay, so that is what we have seen there. I showed you, 0, 253, 254. Okay, now it is in the form of a matrix. This matrix again I want to convert into a single dimensional array. Okay, so this is how the steps are working in the coding. Okay, first the image. In the image is in the form of this matrix. Now this matrix I want to convert into a single dimensional array. It is 2D. This 2D I want to convert to 1D. For that only we are giving the flatten. Okay, this where we use only when there is an image data. Normal data set, like when you're working in NumPy pandas normal data set, that is not a problem. We can directly use it. Since this is an image, we want to convert, the steps are involved. Okay, so when I'm taking a normal data set, like if you are working at diabetics or like house price prediction or like anything smartwatch predictions, so those all, know that data set you can give directly, no issues. Okay, now this is the first time you'd have studied about the image. That's why it is confusing. So how the steps in image classification is, First, the image will be in the form of 2D. Then you have to give flatten the image. Okay, the flatten the image is nothing but it will convert it into a 1D. Okay, why I'm converting this into 1D? So when you're converting the 1D, what will happen? This image will be, so now if it is 0, 0, 0, 0, then 0, 0, 1. Some simple example I'm taking so that you will example 0, 1, 0, 0, 1, 1, 0. So this is like a 2D, right? This 2D I want to convert to 1D. How it will get converted? Simple. 0, 0, 0, 0, then 0, 0, 0, 1, 0, 0, 1, 0. Like this is the conversion. Simple conversion. Whatever it is there here, it has converted like this now. When I'm giving the flatten function. This you got it? So now I'm going to give this to the input layers. So how many input will be there now? I will have 784 input because 28 into 28 is 784, no? So 784 input I'm going to give now. So this will have a 784 input layer. And how many output layers are there? So this is the number 0 to 9. Okay. So there are only 10 output layers. So now I'm just without any hidden layer, I'm going to show it. Then with hidden layer, I will show it. Okay. So now only one input layer, one output layer. How many input? 784. And how many output? 10. Okay. 0 to 9. Okay. So now this will be fed like this. This will be going to all this. Then this will be going to all this. Like this one, the neural network will be interconnected. Okay. Every input to the every output. Okay. Then based on the sigmoid function or softmax function, it will calculate the probability and it will give me the output. Okay. So now I'm using from the Keras, I'm using sequential. Okay. In Keras, we have different layers will be there. This is a sequential layer, input and then output. Like that, it is going in sequence, no? So that's why I'm taking the sequential layer concept. Okay. And I'm taking Keras.layer dense. These are the functions. Now, to give you neural network, this is the format actually. First, we have to give Keras.sequential. Then you give Keras.layers. In this, we will mention the input and output layers all. So, Keras.layers.dense. Okay. And there is no hidden layers, no. So, I'm directly giving this is output layer, number of output layer. And then in shape of the input is nothing but 784. Then activation function, since there are no hidden layers are there, I'm giving directly sigmoid function. If or else no, what we will give, we will go for relu function. Remember, if there is more hidden layers are there, we go for relu. Since this is a very simple network, one input, one output, I gave the sigmoid function. Okay, and then after this, what we have to do, we have to compile it. Model dot, the name of the function here I'm giving is model. So I have to compile the model. So here only I told you about the optimizers, laws, everything, no, that you have to specify. For this only we want to learn about the theory of optimizers, laws and everything. Which laws you have to use. Now guys, tell me, no, which laws to use based on the data set. So this is the categorical data. So I'm giving, because there are many categories are there, no. So there are two types is there, binary and categorical cross entropy. We saw today class, binary entropy and categorical. So this is many categories are there. So I'm giving sparse. This is how this is the name which is present inside there. So we have to give sparse categorical cross entropy. And learning rate I gave 0.01. You can also give 0.001 also. Okay. And the optimizer I'm using here is, what is SGD? What is SGD? Yeah, it is gradient descent only. Today we saw no stochastic gradient descent. Stochastic gradient descent. Okay. I'm using that optimizer. Just I'll keep it here. See, when you keep this here, it will show you what are the functions. Usually, when you keep your arrow mark here, Google Colab will give you the explanation about the function. Okay, it is here. It is not showing. Come to. Okay, so here, depending upon the data set, you have to specify the optimizer, loss, and metric. The metric is nothing but I'm going to calculate the accuracy of the function. Okay, and then I'm telling even this epochs is a trial and error method. You can tell epochs, like you can tell you go 5 times and check, you go 10 times, 20 times, anything you can give here. Okay, and then model first is you have to using keras, take the sequential, you have to mention the layers. Okay, input and output. Next you have to compile it. In compilation you will give all about the optimizer, loss, and metric. So this is like a rule. Okay, you have to follow. After that we will fit it. Okay, we will fit this model to our training. Okay, X train and Y train, and I'm giving the 5 epochs, which means it will go 5 times. One forward back propagation, then backward, forward, backward, forward, backward, like that it will go 5 times. Okay, see, first time. Okay, now see here. First forward propagation, it will calculate the accuracy. Now I got the accuracy in the first time 88.4%. This is nothing but 88.4%. Now again it will go the back propagation. What will happen in back propagation? What will happen in back propagation? We will change the weights, right? So weights will be changed such that my errors will be less. Okay, I'm changing the weights such that my errors will be less. So yes, my errors become less. So that's why my accuracy has become 91%. Again, in the third time, again it is getting 91.6, 91. So my what is that? My accuracy is improving in each epochs. You can try for 10 epochs also and check how much you are getting. Okay, so epoch values you can change. So every time it goes, the error rate. Let us check for. I will give it for 10, but it will take some time. See, every time it is increasing. 87, 87.4, when it is 87.5. Every time, no, the weightage, it will change the weights. Okay. It will update the weights so that no, or your nothing but your y equal to mx plus b, m and c values, it will change. We can give 100 epochs also. If the deep learning is more, no, we give 100,000, but it will take more time to do it. Then what I'm doing is I'm evaluating my model. How you will evaluate your model? Using X test and Y test. I told you, no, we are now training the data set, and then whatever the trained data set, you will test using X test and Y test. My data set, I'm splitting the data set into 280:20. Like that, I will split my data set. And then what I will do, whatever I have learned in the training, it will get tested in the testing data set. Okay. So in the testing also, it is giving me accuracy 86%, which is okay. It is better for the image classification. Okay, then we have to evaluate the model using the test data set. So when I evaluate the model, I'm getting 91% accuracy. So you use the function model.evaluate to do this. Okay, so X test flatten Y underscore test. Okay, then I'm just giving it accuracy as 91. I'm getting the accuracy as 91%. Then I'm predicting now. So whatever value I'm giving, using we will have evaluate predict. So using predicting function, so I'm checking what is the zero value in zero index. What is there? So in zero index, it is showing me the 7. Okay, it is actually is also whatever predictor is also 7. X test is also 7 and Y is also 7. So whatever you have given, it has it has predicted correctly. So you are giving one input, you are giving the input as 7. My model has predicted is correctly as 7. Okay, that is what it is showing here. Okay, so in the training, we learn using testing function, we test whether it is predicting correctly or not. So I'm taking the X test function and I'm checking what is there in the X test of 0th index. In 0th index, I have 7. Then in Y prediction, I'm asking what is 0? Tell me. It is telling 7. So which is means both are matching. So like that, using for function, I'm predicting for everything. So first is 7, then 2, 1, 0, 4. So for first 5 numbers are 7, 2, 1, 0, 4. Okay. For Hemant and Anuradha, what I will do, I will give you a small linear regression coding file. Okay. So this week, no, you just see what is happening. So once you are clear with that, then this you will able to understand.
Yes.
Okay.
Yes.
I will give you those files once I will complete this coding part now. I will give you this files so you both can download and you can just work it and see. I will give you a data set and then a coding file. You can, if you understand that coding part, then this part you will understand from next class. Okay, since it is very new, you will feel a little bit difficult. Okay, this part when you are in the machine learning, this part all will be covered. So I will give you that linear regression file with small coding. So you just see how it is working on. You understand this, that first, and then if you again see this video, you will understand more clearly. Okay. Then I'm finding the confusion matrix. So confusion matrix, this is a method we use in logistic regression to find the accuracy of a data set. So this will give me the matrix form, predicted values, actual values in the matrix form. So more than that, so this will not give you a clear observation. So what we are going to do is using Seaborn. Okay, I'm going to plot this in a heat map. Okay, so what this heat map is telling us, this is predicted and this is the truth. So it has predicted 0 correctly 960 times. Okay, and similarly it has predicted 1 correctly 1109 times. Again, similarly 2 it is predicted correctly 91 times. And what is this 8? Actually it is telling 2 it is predicted as 1 8 times, which is a wrong prediction. And similarly 3 it is predicted as 2 sorry 3 it is predicted as 1 in 1 time. So these are all wrong predictions, but maximum it has predicted correctly. Okay, so 0 it has predicted correctly. So this is what this prediction is. We are sending this epochs, everything, no? So that time it is calculate the prediction, how the prediction was. So 0 and 0, 960 times it is predicted correctly. And similarly, that is what the confusion matrix will tell you. Okay, confusion matrix will give you the detailed analysis, how the prediction was, how accurately it is predicted. So this confusion matrix actually we get in the form of matrix. Now I'm using the Seaborn and I'm making this confusion matrix. If you see, it is in the variable CM. Okay, so I'm telling sn dot heat map CM. Okay, so CM will be this values, whatever the values it is showing in the form of heat map. Okay, so this heat map is giving us a actual accuracy. Whatever there in the confusion matrix, this is showing in the visualization form. Okay. So similarly, if you see one correctly 1100 times, one is then similarly 2 it is predicted as 1 as 8 times, like that. That is the concept here. That is what heat map is showing us. Is still this fine? You just go through the code once, see if you're able to understand the concept what I told you. So main thing you have to understand is image will be in the form of 28 to 20 in the form of pixels, that is in the 2D form. Then for input layers for deep neural network, we have to convert it in the form of a 1D. That's why we are giving a flattening function. Okay, using flattening function, we are flattening it and we are giving in the form of the layers. So then the next step is here, we have to first create a model. What we are creating? We are creating a neural network. How we are creating? Using dot sequential function. Okay, model dot sequential. In that you will specify how many hidden layers, how many output and how many input. So if you see here, we have only input and output. So I'm specifying 10 and then I am also specifying there my input layers. Okay, so this is one part of the coding is over. First step. Second step, what I have to do? I have to do compiling. What I will do in the compiling, I will, depending upon my data set, we have to give what are loss function and then optimizer. Okay, then accuracy. This all you have to accuracy, nothing but metrics. Matrix is nothing but the accuracy score. If it is a linear regression, what are the, you give RMSE, like that we will give R, mean absolute error, like that we specify to find the accuracy. Since this is a logistic regression, nothing but classification problem, we are using the matrix accuracy score. Okay, so that's why I gave that accuracy. So first step is sequential. I mean, first I'm creating a deep learning neural network. After that, I'm compiling it, nothing but tuning it, like using the laws, optimization, and metrics. I'm tuning it. So just you have to get a good accuracy. Once this all done, you have to fit this model. Okay, you have to fit this model to your train. Okay, I'm telling my data set, I'm telling my model, a model, learn from this data. Okay, so for that, you have to give the function fit. This is the third. So first one is sequential, next is compiling, the third one is fitting the data set. So once all this is done, so what we did there, I'll show it from the coding itself. We also will specify how many epochs required. Okay, so first sequential, I'm giving the network, then I'm giving compile and then fit. Okay, then I have to evaluate my model. This is nothing but correction, no? So your teachers or when in the school or college, they evaluate your performance, right? So how you will evaluate using, till now we are working only with training data set. All this three step, this is a training data set. Now it has learned, my model is learning something. Once it's finished learning, we have to test it. How you will test? With the testing data set. Okay, so you give X test and Y test, and you are checking the accuracy. Okay, then if you want to predict whether it is correctly learned or not, okay, you have to use the predict function and predict it. So these are the steps actually. Okay, sequential, compile, fit, then you evaluate the model, and if you want, you can predict it. 5 steps. If you remember, that's it.